Welcome back to our session. In this session, we are going to discuss the rest of the part of chapter 2, polynomials. Children, in our previous chapter, we have discussed about the geometrical representations of zeros of a polynomial, and in this session, we are going to discuss about the relationship of the zeros and the coefficients of the polynomial. So let us start today's session. Children, so to discuss about the relationship between the zeros and the coefficients of a polynomial, let us first start with the general form of a quadratic polynomial. So ax square plus bx plus c is equals to 0 is the general form of a quadratic equation. Here, to find out the relationship between the zeros and the coefficient, we would like to discuss, or we will discuss this with the help of one example. So let us take an example of a polynomial px is equals to 2x square minus 8 plus 6. So I am writing here, our example is px is equals to 2x square minus 8x plus 6. So children, we know that the general form of the polynomial is ax square plus bx plus c. When you compare the given example with the general form, you will see the value of a is equals to 2, value of b is equals to minus 8, and the value of c is equals to 6. So let us factorize this polynomial by using the method of splitting. Children, we know this method, we already learned this method in class 8 and class 9th, that how to find out or how to factorize a quadratic polynomial by using this method. You can see here the middle term is minus 8. So let us split this minus 8 so that the product of this product of 2 and 6 gives you 12. We have to split them such that when we take two numbers, the product should be 12 and the sum should be 8. So I have selected two numbers as 6 and 2 because 6 into 2, the product is going to give you 12 and 6 plus 2 gives you 8. So split this middle term as minus 6 and minus 2, and you know this thing on factorizing, you are going to see two factors. Here we have x minus 1 and x minus 3. These are the two factors of the given polynomial. Now equate both the factors one by one to 0. When you equate x minus 1 to 0 and x minus 3 to 0, you will see that the value of x from here is equals to 1, and from on equating this equals to 0, we have x is equals to 3. So x is equals to 1 and x equals to 3 are the two zeros or the roots or the solution of given quadratic polynomial. Now by using this factorization, we got two zeros. Now let us understand the relationship between zeros of a polynomial and the coefficients of the polynomial. On comparing the given polynomial with the standard form of a quadratic equation, we found here the value of a is 2, value of b is minus 8, and the value of c is 6. And in our previous slide, we found that 1 and 3 are the two zeros of the given polynomial. Now since we got two zeros, children, let us assume that these two zeros are denoted by two letters alpha and beta. So here the first 0 we are denoting by letter alpha and the second 0 we are denoting by letter beta. Okay. So now let us understand the relationship between these things. If we will see the sum of the two zeros, that is alpha plus beta. Here first number is 1 and the second value is 3. So 1 plus 3 going to give you 4, and the product of the 0, that is alpha into beta, means 1 into 3, this is going to give you 3. Now this 4 we can also get. What is the value of b here? Value of b is minus 8. So when we substitute minus of minus 8 upon 2, that is also going to give you 4, because minus of minus 8 is 8. And 8 by 2 is also equals to 4. But this a minus 8 is actually what? It is the value of minus b. Okay. And what is b? b is actually the coefficient of x. And here in the denominator we have 2. Children, on comparing you can see what is 2? 2 is actually A. So A is the coefficient of x square. So this, from here we will see that the sum of 0, that is alpha plus beta, is also is equals to minus b upon A, that is equals to minus of coefficient of x upon coefficient of x square. And similarly, product of the zeros, that is alpha into beta, this we can also calculate. This product of zeros we can also calculate by C upon D. Now what is C? C is the constant term upon coefficients of x square. So from this we can conclude one thing, that the relationship between the zeros and the coefficients of polynomial, as when we have two zeros, alpha and beta, and we have a quadratic equation of the form ax square plus bx plus c, then the sum of the zeros alpha plus beta is equals to minus b upon a, where b is the coefficient of x and a is the coefficient of x square. Similarly, alpha into beta is equals to c upon a, where c is the constant term of your given polynomial upon coefficient of x square. Children, this is very important point, because this point is useful and it will help you to write down the quadratic polynomial. Let us understand this relationship between zeros and the coefficients of a polynomial with the help of examples. So here we have few examples, as we are given with a quadratic polynomial x square plus 7x plus 10. This is the quadratic polynomial given to you. Now what they are saying, first of all find the zeros of the polynomial, and after finding zeros, verify the relationship between zeros and the coefficients. So children, this is a quadratic equation. We will find out zeros by using factorization method. So on factorizing this equation, I am doing it here. We have x square plus 7x plus 10. So again we are using method of splitting the middle term. We want a number, so that we want two numbers, so that the product should be 10 and the sum of two numbers should be 7. So my numbers are 5 and 2, because 5 into 2 going to give you 10 and 5 plus 2 gives you 7. So we will split this middle number as x square plus 5x plus 2x plus 10, and from the first two pair I am taking out x outside. So x in a bracket, x plus 5 is first group, and then from the second we will take out 2, it is x plus 5. So children, you can see we are getting two factors here, that is x plus 5 and x plus 2. Now when you equate these two factors separately with 0, you will get two values for x. Number one, x is equals to minus 5 and x is equals to minus 2. It means this x equals to minus 5 and x equals to minus 2 are the zeros of the given polynomial, or we can also say these are the roots of the given polynomial. So let us denote the first zero by using letter alpha. It means my alpha is equals to minus 5 and beta is equals to minus 2. So as we already discussed, that the sum of the zeros alpha plus beta is equals to minus 5 plus minus 2. So that gives you minus 7, and the product of the zeros alpha into beta is minus 5 into minus 2. Now you know, when you are multiplying two negative numbers, the product is going to be positive number, that is 10. Now let us come back to this point again. Here the sum of zeros we are getting as minus 7. But if you compare this with the standard form, what is the value of a here? Here a will be 1, b will be 7 and c is equals to 10. These values we are going to get. So we have minus 7 here. Minus 7, it means it is minus of b. So and upon in the denominator we have 1, that's the value of your a. So that gives you minus coefficient of x upon coefficient of x square, and the product of zeros we got as 10. What is 10 here in the equation? 10 is c. So we have c upon d, that is a constant term, upon coefficient of x square. So children, you have seen with the help of this example how to find out zeros of a quadratic equation and how to find out the relationship between zeros of a polynomial and the coefficients of a polynomial. Next, another example which is also a very important example in this case is we have quadratic polynomial of the form t square minus 15. Children, you can notice one thing here. In this example, we have only two terms. So the middle term is missing here. There is no middle term, means the coefficient of the middle term is 0 here. So when you compare this t square minus 15 to the standard form of a quadratic equation, you will see a is equals to 1, that we know that a is the coefficient of t square. B will be 0 as there is no middle term in this case, and C will be minus 15. So these are the values of A, B and C. Now in the next step, we will factorize this given polynomial and we will find out the value of two zeros. So on factorizing this, children, we know that 15 we can also write as square of root 15. So this in the next step is going to become t square minus root 15 square. Now children, here I am using third identity to write down this as two terms. This is in the form of a square minus b square, and we know that a square minus b square is equals to a plus b, a minus b. So this in the next term is written as a plus b and a minus b. So we are getting these two factors, a plus b, a minus b, and when you compare these two factors with 0, so you will see that the value of t will be either root 15, positive root 15, or it can be negative root 15. When you compare both these factors separately, when you compare this t minus root 15 to 0, you will get on transposition t will become positive 15, and when you compare this with 0, you will see that t is root 15. So here we got two values for t. It means these are the two zeros of given polynomial, means alpha is equals to positive 15 and beta is equals to negative 15. Again, let us verify the relationship between the zeros and the coefficients. So sum of the zeros, alpha and beta, root 15 plus minus root 15. Children, we know when we are adding two numbers of a different sign, the sum is equals to 0. So root 15 minus root 15 gives you 0, and the product of the two roots, that is root 15 into minus root 15, that gives you minus 15. As one of the number is carrying negative number, so the product is also a negative number. So again come back, here we are getting 0, and we have already discussed here the middle term is missing, means the coefficient of the middle term is 0. So this 0 can also be written as 0 by 1, that is minus b upon a, which is equals to minus coefficient of x upon coefficient of x square. Similarly, here we are getting minus 15, and when you compare this, you can see c's value is also minus 15. So we are getting minus 15 upon 1. Minus 15 is actually the constant term of the given polynomial, and 1 is the constant coefficient of x square. So this is another example to explain you the relationship between the zeros and the coefficients of a quadratic polynomial. Children, now in the next we are going to discuss that when the roots or the zeros are given to you, how to write down quadratic polynomial. So if alpha and beta are the two roots of a quadratic polynomial, then polynomial p of x is written as k. Remember, k is a real number, any real number, in a bracket x square minus sum of the zeros plus the product of zeros, or in short we can also write p of x is equals to k in a bracket x square minus alpha plus beta x plus alpha into beta. So when the zeros are given, this by using this expression or this equation you can frame your quadratic polynomial. Let us take one example here. Example number 1. We have to find out a quadratic polynomial when the two zeros are given to you 3 and 5. So let us assume this first 0 as alpha and the second 0 as beta. So we will first calculate as per this equation. We need to find out the value of sum of the zeros and we have to find out the value of product of the zeros. So alpha plus beta, that is 3 plus 5 gives you 8. And the product of the 0, that is 3 into 5 gives you 15. So we have 8 as a sum and we have 15 as a product, and if we substitute the values here in this equation, so your quadratic equation will become x square minus sum of your zeros is 3 plus 5, that is 8x, plus product of your zeros will be 3 into 5, that is 15. So children, this is very easy. When the alpha and beta are given to you, you can frame your quadratic equation by using this particular expression. Example number 2, you need to find the quadratic polynomial when the sum and the product of the zeros are given. You need to be very careful. Here the roots are given, two separate roots, but here in this example sum and the product is already given to you, that the first number is the sum and the second number is the product. So in the first example, the value of alpha plus beta is 1 by 4 and alpha into beta is minus 1. So directly you need to put this value of the sum and the product in the given expression. So from here your equation or your quadratic polynomial will become p of x is equals to x square minus sum, that is 1 by 4x, minus L product, that is minus 1. And children, you can see this 4 is in the denominator. If you want, you can shift this 4 from denominator by multiplying the whole polynomial by 4. So here in this example, the sum is given to you as 1 by 4 and the product, that is alpha into beta, is given as minus 1. So directly put this value of sum and the product in the given expression to get your quadratic polynomial. So your polynomial here becomes p of x is equals to x square minus sum, that is 1 by 4x, and then plus product. But remember here product is already negative, so it is plus of minus 1, that gives you minus 1. And children, if you keep your answer till this step, it is perfectly okay. But if you want, in the next step, you can remove or you can multiply whole equation by 4 to remove this 4 from the denominator. So it will reduce to p of x is equals to 4x square minus 1x minus 1. And similarly, in the second example, the sum is given to you as root 2 and the product is 1 by 3. So again put this sum and product in the expression. Your polynomial will become, that is x square minus sum root 2x plus product, that is 1 by 3. Again you can see in this example we have 3 in the denominator. You can multiply whole equation by 3, reduce this in a simple form. So your equation will reduce to minus 3x square minus root 2x plus, here it will be only 1, not 1 upon 3. So that's it. This is how you will write down your quadratic equation when the sum and the product of zeros are given to you. Here we are going to discuss about the relationship between zeros and the coefficients of a cubic polynomial. Children, as we already discussed, cubic polynomial is a polynomial with the degree is 3, and we have also discussed in our previous session that cubic polynomial have at most 3 zeros. So let us denote the 3 zeros of a cubic polynomial by letters alpha, beta and gamma. These are the 3 zeros of a cubic polynomial, and this is the general form of a cubic polynomial: ax cube plus bx square plus cx plus d. A is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x, and d is the constant term. And remember here a cannot be equals to 0 as it is a cubic polynomial. So now in this case of cubic polynomial, when you add the 3 roots alpha plus beta plus gamma, the sum of the 3 roots is equals to minus b upon a. Now what is minus b here? B is the coefficient of x square. So minus b by a is equals to minus coefficient of x square upon coefficient of x cube. Remember, these are the sum of 3 roots. When we take 2 roots together, it is the sum of the 2 roots together, that is alpha into beta plus beta into gamma plus gamma into alpha. When we are taking sum of 2 roots taken together once, then in that case this is equals to c upon d. Now when you compare this, what is c? C is the coefficient of x upon the coefficient of x cube, c upon A. Now in the third case, when we take alpha, beta and gamma, means the product of the three roots, then that is equals to minus d upon A. Now what is d here? D is the constant term. So this is equals to constant term upon coefficient of x cube. So children, this is the relationship between the coefficients and the zeros of a cubic polynomial. Let us discuss one very important question which is based on the relationship between and the coefficients of a cubic polynomial. Here it is given to you that 3 minus 1 upon 3 are the roots of the cubic polynomial 3x square minus 5x square minus 11x minus 3. Then we need to verify the relationship between zeros and the coefficients. So again, you know the relation. First we will do alpha plus beta plus gamma, that is the sum of roots. Alpha plus beta plus gamma, that is 3 plus minus 1 upon 3. The sum is going to be 5 by 3. And when you compare this with your given equation, what is 5? 5 is the coefficient of x square. So that becomes minus b by a. Now you take two roots together. Sum of the two roots taken together, alpha beta plus beta gamma plus gamma alpha. So 3 into minus 1 plus minus 1 into minus 1 upon 3 plus minus 1 upon 3 into 3, that gives you minus 11 upon 3. And again compare this with the given expression, it is the value of c upon a. And the third thing, the product of alpha, beta, gamma, when you multiply these three things, you are going to get the product is equals to 1. Now 1 is not there in the given expression, but you can see the value of d in the given expression is minus 3 and the value of a is 3. So minus of minus 3 upon 3 gives you 1. It means this is equals to minus g upon a. So children, in this way, by adding or by finding the sum and the product, we can find out the relationship between the zeros and the coefficients of a cubic polynomial. Thank you children. In today's session, you know, we have discussed about the relationship between zeros and the coefficients, and in the next session we are going to discuss about the division algorithm of a polynomial.